On today's video, we're building a backup power supply from an old tractor battery.
This is the Old Guy Network.
Yep. Welcome back to the Old Guy Network. I'm the old guy, the OG. Jay, you know who you are. And today in the trailer hood, well, we're going to play around with some electricity again. Only this time we're not going to make any large sparks or flames or smoke or like we did last time. That was a whole lot of fun. But no, this time we're going to make what's called a UPS, an uninterrupted power supply. Most of the time these are used for computers. That's what they're sold mostly for. I need one for my laser because when I'm using the laser, and if the burn on the laser is going to take about 5 hours and the power goes out after only 4 hours, well, then I got to start all over again. I don't like that. So we're going to take a tractor battery, battery charger, and an old inverter that we had. And we're going to put those together and make the backup power supply for the laser. And if it works out, later on, we might do this again, only with maybe a couple of different batteries and a little bit beefier power inverter, and we'll do this to the furnace as well, because, hey, it'd be nice to have heat when the power goes out. But let's join my good friend John Jones. He's a master electrician. He's out waiting in the shed, so let's get out there now and put this thing together. Hey, we're back in the shed, and John's with me again. And if you don't remember who John is, well, you're probably better off. But he is a licensed master electrician, and today we're going to do something that's going to be a little less dangerous than the last thing we did, I think, right?
Hopefully.
Okay. John, thanks for being here.
Absolutely.
Appreciate it. Still dressed the same.
I always dress like this.
I know you do. What we're doing today, you probably saw from the thumbnail, we're actually going to make a battery backup, what's it called, a UPS, uninterrupted power supply. And we're going to do that with a deep cycle battery that John has right here. And these batteries, brand new, are what, like $1,500?
No. These are tractor batteries, maybe $300 or $400.
Oh, $300 or $400.
Yeah.
Okay, these are not the same ones you talked about before. No. Could have filled me in. But anyway, all right, $300 or $400. But out of the goodness of his heart, he's letting me have this for well, nothing, right?
Yeah, pretty much.
Good. Pretty much. Or I have to buy him lunch. That's okay. I don't mind that. You eat light, right?
Yeah.
Okay. What he's doing now, he's setting up the terminals for the battery. Now, this battery is, how many watts is this?
It's a 1200 amp battery.
Okay.
12 volts. Wattage, of course, would depend on load.
Right. And what we're going to do with it is, when I'm running my my laser, if the power is interrupted and the laser stops, well, I'm done. And some of those burns take about 5 hours. So if I'm 4 hours in and the power goes out, well, I'm pretty much screwed. So I want to run this uninterrupted power supply so that if the power goes out, hey, this will kick on, or it'll actually run off this, and I'll be okay. So we're going to use an inverter. We're going to use this battery, and we have another component, voltmeter?
Charger.
Oh, and your charger. So this is how a UPS works, and I used to use lots of them when I had my computer shop. The device, and our device is going to be the laser, although the laser's not out here, we're going to test it with the belt sander. But let's say with the belt sander, I want to run that just off the battery. We plug the charger into the wall, that goes to the battery, that goes to an inverter, which makes it from DC, direct current, to AC, which is alternating current, which is what you use for your bandsaw or sander or whatever the hell it is you're doing. It's really, really simple. So let's watch John at work. You want to explain anything, or is it pretty much?
Well, we have here a 12 volt, 1.5 amp battery charger just to maintain the charge in the battery.
Right.
So you'll be using current off of this. It may not be able to keep up with actually what it's putting out. However, the load is not a constant load, so this will constantly be charging.
Right.
It will maintain it.
We just don't know how long it'll last.
Well, that's depends upon the load of the laser,
Right.
and the computer and whatever. If we find out that it's using too much of a load, we can bump up to a bigger battery charger.
Right. Now, the other thing that we've talked about, might have to, like you said, we might have to get a bigger battery charger. And I don't know about the inverter that you have here, but we talked about running this for the furnace.
Yes.
When I do get a furnace, when I get a new furnace in here, actually putting a power supply backup, a UPS, on the furnace. And, with any luck, if we have a good battery, we have it fully charged and don't have too much of a draw for current, we might get a couple of days out of it.
Right.
So that's something to think about. But for now, I just want to run the laser without it going off and making me really, really mad. So right now, he's just hooking up the charger to the terminals.
Just as basic as it gets.
Yeah, this is pretty easy. Anybody can do this part.
Just make sure you don't touch these two terminals together.
Right.
There is a lot of power there.
And it never stops.
No.
It'll keep on going until it's dead, and that's not good.
It will make it warm very quickly.
Yeah.
Ask me how I know about that.
And remember, John is a licensed master electrician, and he pretty much knows what he's doing. And if he doesn't, well, then it'll be pretty
I just
entertaining.
make it up as I go along.
Yeah, pretty much. But this is pretty cut and dry.
These are all salvage parts out of electrical equipment that one part or the other has failed. We scrap it out, we throw away or recycle what we can, and salvage the pieces that we can, try to give them new life.
And I'm all about reusing stuff. My whole life is based on that. Everything I have used to be something else.
So we're hooking up the 120 volt side that's going to power the charger. This does not have a power cord on it because, as I said, it was part of electrical equipment and it was mounted inside of a cabinet. So there was no need to have any power cord. It was powered directly off of the main bus bars. There. So let's find out what we're putting out for voltage currently. That would be 12.53 volts. We'll plug this in and see if that kicks up and find out if we've got a good charger. There you go.
So it's charging at
It is now
12.95.
Correct. That should, when it's all done, it should settle out around 13 volts. You take the charger off, it'll bounce between 12.8 and 13 volts. That's about.
Yeah, you're almost at 13, right? You're at 13 right now.
And it may actually overcharge for a short period of time and then stabilize back down to 12.8 to 13.
It's almost like you know what you're talking about.
Almost.
I met John when I had my computer shop. John used to like to bring his laptop in because he would get into a condition where he thought he could fix it. How'd that go, John?
I'm no longer allowed to fix my computer. Ever.
And I don't fix his computer anymore, so he had to go to somebody else. But that's how I met John, and we both like doing stupid things, so we get along fine. We're at 13.13, so that's, 13.13. Wow, now it's jumping. All over the place.
Yeah, and it will.
Okay, so that's the first step. Now the battery is being charged.
Correct.
So now we have to hook up the inverter.
Now let's...
I say we, but I mean John.
Right. So we're going to take our handy-dandy 700 watt.
That looks familiar.
It should.
You bought that at my pawn shop.
Several years ago. Well, many years ago.
Yeah, no, a lot of years ago. I closed the pawn shop 4 years ago.
So let's make sure it's off.
And you've been using this all along.
I have. I use this when I do service work to run a small vacuum cleaner or to charge batteries or whatever.
Well, and like I said, an inverter, basically, it's just going to change direct current to alternating current.
Correct. There, close enough. Alrighty, so now let's do something completely different. We'll jam our probes in here.
Okay.
And we'll switch this to AC. There should be nothing.
And we're close to nothing. We're at 0.7.
Correct. And then,
Oh, man.
now we're running 113 volts DC.
All right.
Now let's see what kind of a difference that's made on our battery.
We're still
So,
at 13.47.
Yeah, no load yet.
No, we're good.
I'm going to leave this on DC to see if anything happens. And I'm going to knock over the meter.
I think your meter's drunk.
I think you're right. Let's see.
I think it's plugged into the strip, isn't it?
Yep. I was just wondering which one is which. Because this one...
Yeah, that's it. Now the next thing is, will the cord actually be long enough? There it is. All right. John, you want to do the honors and turn on that belt sander? There, it worked for 0.5 seconds.
May not have had quite enough current to get it started.
No.
No, not quite enough.
Well, that's important to say, too, that things when they start, an electrical motor, when it starts, it needs a lot more amperage just to start, and then it drops down.
This runs at 4.3 amps constant, but to start up, it draws almost 40 amps.
Yeah, so that's not going to work. But we have another plan. Now this should be very close to the laser, because the laser doesn't really draw that much current. And that is this light.
A light. I'll hold the light.
You hold the light. I'm going to plug it in if I can. And turn that on, John. Oh!
And it works.
Yeah, you're blinding me. You blinded me with science. So we know this works, but the only real test is after I hook this all up in the house. And we're not going to do that today. We're just showing you how to make this UPS. And if we were to buy everything brand new, the battery, like you said, let's say high $400.
Let's say 400. Let's say decent charger, $50, $75.
Okay.
An inverter. Now this is a small inverter. They run about 75 to 100. The inverter that I have in my service truck is about 600.
So it would be fair to say under $600, you could actually make one of these that would run your furnace.
Yes.
Probably wouldn't run too much else. Your furnace may be a light.
Run one or two things at a time.
Right.
Now to compare, they have battery packs now where you plug them into the wall or you hook a solar panel to them, and they're capable of running refrigerators, freezers, furnaces, pretty much everything you have in the house. But they also cost $2,000 to $3,000.
Now, one of the reasons why John knows about all this, John, what's the name of your company?
Electric Power Systems.
That's right. John actually does power systems, as the name states. He mostly generators, but you have dabbled in solar panels and
we do some that are solar panel coupled, off-grid generators, solar, and when the solar is out of commission for several days, snow, poor weather, whatever, it'll kick the generator on. And that's where I'm primarily concerned, is to maintain and keep those generators running.
And we'll put a link to your company right in the description too. So if anybody has any questions for John, he does actually do business all over the state of Maine, and he can answer questions to anybody. Well, if somebody from Yugoslavia calls you up, you can probably talk to him, right?
Absolutely.
Well, with an interpreter. But all right, this is a very simple thing, and a lot less dangerous than the last one we did. So it's not exciting, so I'm not really that happy.
We can make it exciting.
We'll save that for another video.
There you have it, another successful project with my friend John Jones, who is a master electrician, and because of him, we didn't burn anything down, so we did really, really well. If you have any questions about UPSs, power supplies, generators, solar panels, or
Life in general, probably. I don't know. You can get a hold of John. I will leave a link in the description of his company, EPS. And he's a great source, great resource for information. He does this kind of stuff all the time. So thanks again, John, for being here. And I appreciate you being here and watching this video. If you like the video, please hit like, share, subscribe. Hit the notification bell when you do subscribe so you don't miss any videos. I'll see you back here in the trailer hood next time for the Old Guy Network. I'm the OG, and I'm out.